Okay, we start method class. We talk about composite body here. Okay, we learn about central of area or central of variant. Actually, they are highly relevant to the composite body. Okay, here are some supporting cross section for different structural element. And right hand side, this one, that's the most simple, most popular beam we can see everywhere. So actually, like this cross section, we have to work out the central of area because it will influence our further knowledge, and they will be discussed in a further topic. Okay, so this table show us for different area calculation, and then we also can work out a central of area for x value and for y value. Okay, they are average value. Here are the basic cross section. Of course, if we have a complicated cross area, so probably we need to use a concept learned before, which is equation listed above here. Okay, example 9.10. For this area, we want to work out a central for this area. Okay, of course, from this figure, we can see the area is irregular, and probably it looked like very complicated. However, the solution is not that difficult. First of all, we can add one more area here. Okay, you can see right hand side we have a cross section area 3. So we make it become a full area and do the calculation. And then later on, we use a superposition concept. We just cancel the effect come from this area, and then we can work out our solution. Okay, so we have look what's the procedure of all. So first of all, we add up the area 3, and then we make it become a, I saw this is a square. We make it become square for area 2, and area 1 is a right triangle. And then we work out an area for area 1 and area 2. So area 1 is right triangle, so we know the side is 3. So for area calculation is 3 squared divided by 2 because of which is a triangle. And then for area 2, the side is 3, so the area is 3 times 3, which is 9. Okay, then we have look the central of area for segment 1. So central of area, we see the reference which x-axis is here, and then y-axis is here. So the level arm to x-axis, the distance is 1, and the same, the level arm for y-axis, the distance is also 1 because which is a right triangle. And then we use distance times by area. So for this moment, moment of area, which is 1 times by 4.5, so it's a 4.5 here. So for moment of area to y is also 4.5. Okay, then we have look the area 2. Because we define x value 0 is here. So for the central of area for segment 2, the distance, the level arm is negative here. So we have area 9 times by negative 1.5, which is negative 13.5. Okay, because the direction here is negative. Okay, then for y value, which is positive, because they are all above x-axis, so there is no doubt, which is 1.5. So we use 1.5 times by 9, and then we got 13.5. Okay, then for segment 3, because we add up segment 3 on it, so right now we have to minus the effect come from segment 3. So for area segment 3, which is negative, because we have to minus the effect of it. So for area is 2 times 1, so it's negative 2. And then for level arm, x also minus, because it's calculated from y-axis is a negative x value. So the average distance is negative 2.5. And then for y value, the level arm is 2. So we use area negative 2 times by average x distance, negative 2.5. So negative times negative, so it becomes positive. So for moment of area for x become positive 5. And then we have area negative 2 times by level arm, which is positive 2. So for moment of area, y-axis is negative 4. Okay, then with summation of the moment of area for x, which is negative 4, and for y, which is 14. So we use those values divided by total area. Okay, total area is the summation of area here. And then we can work out the central for this area. X value is negative 0.348, and then y value is positive 1.22, okay, meter. So which is calculated from the 0, reference point. Okay, so overall procedure has been described in previous slide. So we add up the area to make this segment 2 become a full square, and then we work out the effect for these two areas, and then later on we minus the effect from the adding segment, and then finally we can work out the central for this irregular shape. Okay, so the same concept, we can use this approach working on different irregular shape. Okay, they all use the same concept. Okay, so right now we see the other example 9.9. So for this example, we can see this part is half circular, and this part are two straight lines. So the same, we want to find out the central for this wire. Of course, we can divide this wire into 3 different parts. So as shown the figure below here. So you see segment 1, Y1 here, and Y2 here, and Y3 here. Okay, then we divided this wire into 3 different areas, so we can work out the length for these 3 different segments. So for this half circular, so we can directly use radius. Okay, radius, 2 radius become diameter, but diameter times by diameter times by pi become full circle. But full circle we should divide it by area, and therefore it becomes 60 times by pi, so which is the length here. So the length is 188.5. Okay, then segment 2 is 40, so it's a given information, and segment 3 is 20. And then for average x value, so x-axis is here. So because it's a symmetric condition, so average x is 60. Okay, average y value, okay, here, because we define positive y is here, positive y is here. So this value is negative 38.2. Okay, so for the center of y value, this point, we have a similar example. So we go back to the previous slide to check. Wait for a moment. I go previous slide to find the average circular. Okay, which is here. So as I mentioned previously, I saw last week, the central point we work out, which is we have x value and y value here. But if we have our shape is half circular, so if half circular this way, and y value, average y value, there is no change, so still at this point. So we can directly use 2r divided by pi as the average value. So we can work out the later example, 2r divided by pi. We use 2r divided by pi. Okay, so you can see from the equation here shown, the average point is 2r divided by pi, so which is 38.2 millimeter, and it's negative. So we have negative value here, and z is 0. So the same, we use x level on x times by length, work out this value, and y value, which is negative, times by length. So we work out negative value here, and here is z value, and z is 0. So it doesn't matter what's the length. Z is 0 here. Okay, for segment 2, length is 40, and its segment 2 is a long y-axis, and therefore average x is 0, and average y is 20, because overall the length is 40, so halfway the central is 20, and overall z is 0, and then we can work out for level on y times by L. which is 800. Okay, then for a segment 3, we have the length is 20, and then for average y value is 40, okay, 40, which is here, and average z value is negative 10 because calculate from the xy plane, so it's downward, so it's negative 10. And then we use 20 times by average y and average z. We can work out 800 here and negative 200 here. Okay, we know the overall length is this value, 248.5. Okay, then we know summation of average x times the length is this value, and summation average y times by length is this value, negative 5,600, and summation average z times by length is negative 200. So we use those summation divided by summation of length, so we can work out average value for x and for y. This one is x, this one is y, and this one is z value. So x is roughly 45. Okay, roughly 45. 45, okay, about here. And y is negative 22. So positive 22. Okay, z is downward. So roughly the central for this wire is about this point. Okay, then this is example 9.11, and this question a little bit complicated. We want to find the center of the mass, and remember the density rho c for this conical frustum have a density rho c is 8 megagram per meter cube, and hemisphere has a density rho h, which is 4 megagram meter cube. And then there is a 25 millimeter radius cylindrical hole. Okay, cylindrical hole is here, which is in the center of the frustum. Okay, so if we want to work out the center of this mass, you see the procedure. Okay, I saw from the procedure it's easier for us to explain what we work out. Okay, so we can make this shape become a cone, look like this. Okay, then bottom is a hemisphere. Okay, then later on we know inside here, which is a cylindrical hole. So cylindrical hole, which is this one. So we have to minus the cylindrical hole here. And then we make this shape become cone. How do we make it? We add one more cone above here, which is segment 3. We make the additional cone above here. So we have to minus the cone, which is segment 3. Okay, so we work out segment 1 and segment 2. and then we minor segment 3 and segment 4. That's the overall procedure to work out this. Okay, so for cone, we know the central for the cone shape, which is 1/4 calculated from the base area, 1/4. Okay. And then for the hemisphere, I check whether we mentioned this in previous slide. Let me think. Oh, okay. Okay, I saw it didn't show in our lecture note, but it can be checked from some from the textbook. So for hemisphere, the central is 8 radius, 8 radius. Okay, which is a 8 radius, and then it gives us a value is 18.75. Okay, then we minor the other coin for segment 3. So the central is this. And then for cylindrical, of course, the center is middle. And then later on we check. We have to work out the mass. And then for the mass, we calculate the base area, which is radius times by radius, so it's a 50 square, and times by pi, so it becomes area. And then it's a cone shape, so we use the area times by height and divided by 3, which is a variant for cone shape. And then we times by density, so it becomes mass. Okay, 8 times by 10 power of -6 is density. Okay, so we only need to work out z value. So for z, this point is 50. Okay, for the second area, so we use the variant to calculate a ball. So the same, we use the 50 cube times by pi, and then this part is to calculate a hemisphere. That's a variant for hemisphere, and this part is a density for hemisphere. So we work out the mass, which is here, and z value is negative because we define 0 is an interface along between the cone and hemisphere. Okay, then this part is the other cone. So the radius become half, and the height also 100, and then that's times by pi, and then divided by 3, which is a cone volume. Okay, then this is the density. But for this mass, we have to minor because originally we don't have the cone, this small cone here. So we have to minor this segment. And then level on is 100. 100 is this plus 25. Okay, so it's become negative value here. Okay, then the final one is cylindrical. So pi r square and times by height is 100 times by the density. So it becomes the mass. So which is negative 1.571. So level on is halfway 50. Okay, so we use mass times by different level on. So we can work out mass times by level on for different values. So summation of them. So we have a mass, a moment of mass divided by summation of mass. So we can work out the central for z value, which is 14.6. So 14.6, roughly this point. Okay, anyway, this example looks complicated, but it's not a popular shape. We will see this kind of design. So right now, we see this example. This example is a more popular example. We can see for civil or mechanical system. So we want to determine the location for the y value, average y of the central of C of the beam having a cross-sectional area shown. Okay, so we can see this structure left-hand side and right-hand side is symmetric, but top to bottom, which is not symmetric because here the dimension is 100 millimeter, but here dimension is 150 millimeter. So of course, to solve this equation, there is not just the only approach. We can use many different approaches, but up to you. So here for our solution, we only use one approach. So shown next page. Okay, so we can see let's divide this segment becomes 3 different areas. So area 1 is this part. So area 2 is this part, and area 3 is this part. So for area 1, 150, which is a base, and height thickness is 15. And then we know the level on come from here. Halfway is 7.5. Okay, this part. And then for second area, we know we know this height is 150, and times by thickness, which is 15, 115 times by 15, and then level on is 150 halfway 75 and plus 15, so which is 90, and that's a level on. Okay, then for the bottom is 100 times by 15, so 100 times by 15, and then level on is 100. Here is 15 plus 150, which is 165 plus 7.5. so it's 172.5. Okay, so moment of area summation already work out. So divided by uh, summation of area. So summation of area is this one. So we can work out roughly the central for y value is about 80. Okay, so work out 80. Okay, 80 is roughly here. Okay, so for chapter 9, okay, here is chapter 9. We don't have any assignment homework, but all of you should still get familiar with example teaching in this chapter because in the future topic you will still need to use it. We don't have homework. It is due to right now it's very close to end of the semester, so probably I give you more time to prepare the content, and then you can have more time to prepare your exam, including other subjects. Okay, let me think. Okay, anyway, you should have a look this topic, and because they will those content will be used in material mechanics. Okay, right.